Welcome, welcome back to reciprocal functions. We're going to look at the general shape of tangent and cotangent functions in this video. The functions tangent and cotangent have periods pi. This is clearly a different period from sine and cosine in their reciprocal functions. This means that if you have tangent of an angle plus pi, you get right back to tangent of theta, or the angle. And similarly with cotangent, if you have cotangent of theta plus pi, that is also equal to cotangent theta. Now, let's fill out the following table using your calculator. I would highly recommend you just pause the video and fill this out for practice. Remember, you need to make sure your calculator is in radian mode before you do any of these tables. Welcome back. So what you should have got when you used your calculator to find the table is tangent of x will equal an undefined value for negative pi over 2. This is when the sine over cosine, remember tan x equals sine x over cosine x. That means that you will have a cosine that's equal to 0 at negative pi over 2. And also at pi over 2. So then the rest of the values are mirror images of each other, which is kind of cool. They're symmetric. So you can have a negative pi over 3 as your x, and you get negative 1.73. At tangent of negative pi over 4, you get negative 1. At tangent of negative pi over 6, you get approximately. The exact value is negative root 3 over 3, but the approximation is negative 0.58. At tangent of 0, you get 0. At tangent of pi over 6, you get approximately 0.58. At tangent of pi over 4, you get 1. And at tangent of pi over 3, you get approximately 1.73. Remember, the last value here is undefined at pi over 2. Which means I can now draw my vertical asymptotes at the undefined values. And now I'll draw in my points that I found in the table. This is not perfectly to scale, but for sketching purposes, I think you'll get the idea. At negative pi over 3, I'm going to go down approximately negative 1.7. At negative pi over 4, I'm going to go down approximately 1. At negative pi over 6, I'll go down negative 0.58 on the y-axis. And at 0, I'll be at 0. At pi over 6, I'll be at 0.58. At pi over 4, I will be at 1. And at pi over 3, I'll be at 1.7. And then I'll be undefined. So if I were to draw a line through these, this is a little trickier to sketch. I think that's why it's so hard to kind of wrap your mind around tangent. But it curves in, it changes direction. So instead of curving downward on the left, it's curving upward on the right after you pass 0. And then it tends toward the vertical asymptote. This repeats over and over and over again. And if you were to sketch it in your calculator, have your calculator graph it, it would give you a whole long pile of these to the left and right based on how your window is. The domain for this function can be written in set builder notation or set notation, depending on how you may hear it, where we say that x is an element of the real numbers, or all real numbers, where or such that x cannot equal n pi over 2. What that means is multiples of pi over 2 or negative pi over 2. But we can't just say that because that would include 0 times pi over 2, which clearly exists on our graph. So we would then have to say where n is an element of the integers and n cannot equal 0. That is a lot of information. Another way you can say this is your domain for one period exists from negative pi over 2 to pi over 2 with not including the sides either side because those are vertical asymptotes. Now remember, if you use the second option here, you have to also say for one period of tangent about the origin, because otherwise it just looks like you don't know that it repeats. You could also say this is the period about the origin where it repeats every pi over 2 for a period of pi. Hopefully that makes sense. If that doesn't, you might want to do a little bit of reading about this in your textbook just to kind of figure out what you're missing. This is very important. The range is from negative infinity to infinity. We now need to graph the cotangent into a table so we have some values. I'm just going to go ahead and fill this out, and I encourage you to also use your calculator in radian mode and fill this out as well. You can go ahead and pause the video if you want to try and fill it out on your own. I can see from my table of values that my vertical asymptotes are at 0 and at pi. Then I can fill in all the other values. At pi over 6, I'm at 1.73. At pi over 4, I am at 1. At pi over 3, I'm at 0.58. At pi over 2, I'm at 0. At 2 pi over 3, I'm at negative 0.58. At 3 pi over 4, I'm at negative 1. At 5 pi over 6, I'm at negative 1.73. And so you can see how this, if I connect the dots, I'll get a cotangent curve. And again, we're asked what the domain and range for cotangent is. As you can see, this would repeat every pi. And so I know that for my repetition of the domain, I could write this in either set builder notation, or I could write it as a single period. So for one domain of one period, we'll say about the origin, because this is the closest one to the origin and it's positive, we would say your interval is from 0 to pi, not including the endpoints. But let's say we wanted to be more precise. We could say the domain is the set of numbers where x is in the real numbers, so it's all real numbers except for, or such that, we have x cannot equal n pi, where n is an element of or in the integers. So this would throw out any multiples of pi, including 0, which is what we want here because we have a vertical asymptote at 0. Now let's look at the range. The range is from negative infinity to infinity.